Yeah. Yeah, good evening everyone. So before I start, can anyone please confirm whether my voice is clear, whether my screen is visible or not?
Yes, I can see you are. Yes,
Yeah, fine. Thank you for the confirmations. So
thank you.
I'm Vijay. I'm Vijay. I hold 13 plus years of experience, which includes 7 plus years of experience in Hadoop and Spark environment. So as part of today's demo, just I'm going to discuss the following things. What is big data? Why Hadoop? Drawback of databases. What is big data? Why Hadoop? Drawback of databases. Hadoop advantages. Okay, and Hadoop job market. Okay, what is big data? Why Hadoop? Drawbacks of databases, Hadoop advantage, Hadoop and Spark job. That is what I'm going to discuss. So what is big data? So the name itself saying huge volumes of data, right? The big data, huge volumes of data.
Data.
See currently how the data is getting stored. What are the data storage units? We say like KBs of data, MBs of data, right? KBs of data, MB of GB, gigabyte,
GBs of gigabyte,
petabyte,
megabyte.
petabyte, exabyte, zettabyte, petabyte, petabyte, so on. So from TB onwards, we say it as big data, right? Huge data generation. From TB onwards, we say as huge data generation and big data. We say you should have seen KBs of data or MBs of data or GBs of data, or even you should have seen like TBs of data generation. Do you think like petabytes of data or exabytes of data is it getting generated in the current real world? If so, examples of petabytes or exabytes of data generation. So like 1 petabyte equal to 1024 TBs. So what are the examples for petabytes of data generation? So like if you take,
Banking, Facebook.
yeah, if you take banking side, if you take any bank, so within it today, if you see in every state you have got a branch for a particular bank like SBA or HDFC. So in a city you see like hundreds of branches for a particular bank, right? Within the entire
Yes,
state, thousands of branches. Please be in mute, I'm getting sounds from someone. Yes, with within the entire country, lakhs of branches for a particular bank. Again, within the each branch you see millions of customers, lakhs of customers, each customer making multiple transactions per hour, per day, per week, per month, per year. Each and every transaction need to be stored, right? So like huge data is getting generated. And if you take social media, if you take any social media applications like Facebook,
Twitter.
Facebook has Facebook has got users not only within the country, it has got users throughout the world, right? It has got users throughout,
Yes,
millions and trillions of users for Facebook. So in a minute, how many posts and videos are getting circulated, how many posts and videos are getting circulated, what should be the storage capacity of Facebook. So do you think like MBs or GBs of data, is it getting generated in a minute or in a hour? So like TBs or petabytes of data is getting generated. So huge data is getting. And not only like Facebook, today if you see any application, if you take just 1 minute transaction itself, just take 1 minute transaction itself, you can see huge data is getting generated. In a minute, how many FB posts? What is the data generated by Facebook in a minute? Huge data, right? And if you take
Yes.
not only like Twitter tweets, huge data generation from the Twitter. And if you take the example of Google today, everyone, if you get anything, you can just Google and check Google queries. What is the data generation of Google queries? In a minute, what is the data generated by it? And if we take everyone, just they are creating their own videos and just uploading in the YouTube, right? YouTube videos upload. YouTube videos upload. What should be the one second? YouTube videos upload. What should be the storage? Yes, I am getting sounds again. One second, let me check. Okay, so please be in mute. Whenever you have, you can just unmute yourself and you can just ask your queries if you have got any. At the end of the session, I'll be giving time for your further queries. Fine. But I want interactive sessions itself. But if you see that if there is any background noise, so see that you can just respond through chat panel. Fine. Now, like email or Gmail messages, millions and trillions of people using email or Gmail messages, right? What should be the data generated by this email or Gmail? What should be the storage capacity for storing all the messages? And just now I was discussing about bank transactions, right? So what is the data generated by this? Okay. And if you take the example of telecom transactions, and if you take example of e-commerce website like Flipkart, Amazon, e-commerce website like Flipkart, Amazon, for all this huge data is getting generated, right? So these are the examples of how the data is getting generated, the applications which are generating huge data, not in GBs or TBs, but in petabytes. And an average, if you take Google generating nearly 800, more than 800 plus petabytes per month on an average. On an average, I'm saying 800 plus petabytes per month on an average. Huge data, right? 800 into 1024 TBs, that is what the data generated by it. Already 1 TB is a large storage unit, but 800 into 1024 TBs, that is the data generated by it. It's not only like Google, if you see like Facebook, Twitter, YouTube, e-commerce, I mean all the social media applications, other things that are generating data. Fine. So we need to have proper storage systems for storing this. Not only storing it, processing the data is also important, right? Currently we have got databases, like if we take example of Oracle, MySQL, DB2, SQL Server, all these they are used for OLTP, online transactional processing, for day-to-day operations. But we have got some specialized databases like Teradata,
That is a
Netisha, Vertica. These are used for OLAP, analytical processing, for data warehouse, TWH. Okay, fine. So if you take this up to, they can extend up to, they can store data up to some extent, but they cannot store unlimited data. Huge data storage is not possible by this normal databases or by the specialized databases. Specialized databases like Teradata, Dija, Vertica, they can handle up to some extent, but I cannot say like huge data, unlimited data can't be handled by this. Now if we take examples of the data generation, if you see the data generation from the last, if we go back and see the last 50 years of data generation, for example, this is the entire data. This is the data that is available in the current real world. This is the total data which got generated from the last 50 years, assume. Think from 1970 to 2020. If we observe this data carefully, like nearly 80% of the data, this is 20%. 80% of the data, I'm just making it into two. 1970 to 2005 or 2010. If I take last 10 years data, if I take last 10 years of data and previous 40 years of data. Okay, if I compare it, if I compare this data, then 80% of the data has got generated from the last 10 years itself, right? 80% of the data got generated from the last 10 years, but previous 40 years only 20% of the data is got generated. Reasons for what? Huge data generation here, especially from the last 10 years. Can you see what are the reasons for huge data generation, especially from the last 10 years? Because of usage of technology, because of usage of technology, because of usage of smartphones, and because of usage of internet. Yes, I'm getting sounds again. Please be in mute. Okay, because of usage of technology, smartphones, and internet. So because of usage of this, huge data is getting generated, especially from the last 10 years. Today, if you see everything through internet, online banking, online shopping, online exams, online education, like e-learning, online gaming, online healthcare, online communication, audio, video chatting. So huge data is getting generated, right, everywhere. Even because of usage of smartphones, also huge data generation. But if you go back like 20 years or 25 years ago, 1990s, the data generation was very less. Even if you see how the data is getting carried in 1990s, how we used to carry the data, 1990 or 95, floppy disks. Floppy disk, you used to carry floppy disk, 1.44 MB. Later you got compact disks of 700 MB. Later like DVDs. Okay, next you got like USB pen drives, all this. Now if you see that even GBs of data you can store, but day by day if you see data is increasing enormously, right? So we need to have proper storage system. So how the data is getting generated, and especially this 80% of the data, what are the main sources from where this data is getting, what are the main sources from where this data is getting generated? Mainly I can say three sources from where this data gets generated. Three sources of data, like social data,
Banking
machine
data.
data, and transactional data. The data which got, what is social data? The data which got generated from social websites. The data which got generated from social websites like Flipkart, otherwise Facebook, Twitter, all this social media, like Facebook, Twitter, all this. Machine data means, for example, the name itself saying the data which got generated from the machines, means if you just go to a shopping mall, for the items you purchase, a bill is going to get generated, right? A bill is going to get generated. So the data is not the data which got generated, the data which has got generated by reading the barcode scanners and RFID chips. Such kind of data we call it as machine data. What is that? Reading the barcodes, scanners, RFID chips. Such kind of data we call it as machine data. And transactional data, nothing but day-to-day operations like bank transactions, telecom transactions. And if I take, these are the mainly three sources from where this data is getting generated. And if we discuss like types of data, types of data, structured data,
Structured data.
semi-structured data, unstructured data. Structured data, semi-structured data, and unstructured data. Structured data means data which is arranged in the form of rows and
Columns.
data which is arranged in the form of rows. The data which is arranged in the form of rows and columns in a structured format, like Excel sheets, database tables. Okay, semi-structured data like XML,
JSON format.
JSON, JavaScript, object notation, all this. Which they are not fully structured, they are not fully unstructured. They are not fully structured, they are not fully unstructured. Unstructured data means
data which is generated from Twitter, Facebook, maybe images,
chart messages, articles, pictures, videos,
Logs.
all this, yes, all this comes as unstructured. But today the biggest challenge is handling the data, handling all these varieties, three varieties of data: structured, semi-structured, and unstructured data. But if we take the examples of the databases, they can handle only structured data, right? But this kind of unstructured or semi-structured can't be handled. But to handle all the varieties of data, we need to have a proper tool. Okay.
Hiva.
So as a solution to all this, storage level and processing level issues, we got a framework called Hadoop. We have got a framework called Hadoop, which stores that huge data and process huge data in quick time. So what is that? Hadoop. It's a framework which stores huge data and process that huge data.
Then process and storage.
Storage happens and also processing. Hadoop is provided two services. Hadoop is going to provide two things: huge data storage and huge data processing. Huge data and huge data processing. Okay, if you take any technology, it performs either storage or processing, right? If you take the example of C or C++ or Java or Python, all those, they are used for processing, right? They are not going to
Processing.
store the data. So like Oracle, MySQL, DB2, all these, they are used for
Storage purpose.
so either storage or for processing. But Hadoop is meant for both storage and processing. So here I'm giving a statement like Hadoop is meant for both storage and processing.
Processing.
That unlimited data storage and unlimited data processing. There is no limit on or the data stored by Hadoop, and processing also the same. So I got some couple of queries here. You may ask like, if Hadoop there in the market which can store and process the data, then why all these processing technologies in the market? When Hadoop is able to store and Hadoop is able to process this data, then why all this processing and storage technology, they may go away from the market, right? So now Do you think that they are not required? Java, Python, C++, C, or Oracle, whatever we are using currently. So you need to understand where exactly what kind of applications you can develop by using this Hadoop. And okay, so you need to Hadoop is meant for batch applications or batch processing. Hadoop is not for OLTP, online transactional processing. Hadoop, for example, you made a single transaction. For a single transaction, no need of Hadoop, right? Millions of transactions, then go for Hadoop. But here, Hadoop, using Hadoop, you cannot perform OLTP, online transactional processing. If one transaction or two transactions, three transactions, whatever it is. For that, Hadoop is not required. Millions and trillions of transactions, then Hadoop required.
One thing here in this Hadoop, we are using the Java at the same Python also, no?
1 second. I'll come back to that. What are the things you are going to use? Okay, fine. Means generally, if you take any technology, general implementation goes in some language. We require some language actually for implementing the concepts. Okay, so here you need to Hadoop cannot perform online transactional processing. It performs what? Batch processing. Hadoop is meant for batch applications or for batch processing. So you need to clearly understand online transactional processing and batch processing. Okay. So what is the main difference? Which is advantageous? Which has got more load? Online processing means what? There are two types of applications. You can say like two types of applications: online applications, batch applications. And batch applications. Online applications, example of online applications, here where user interference required. Here user not required. User involvement, there is no user involvement. But in online application, user involvement compulsory, right? For example, you are making a transaction, you are transferring some amount,
OTP.
compulsory user is required, right? User entering that account details or the bank compulsory. If you're making any online transaction, user required. If you're booking a movie ticket, you require, right? Automatically it won't be generated, right? User need to perform the things. Or if you are railway book a ticket, that is booking a ticket, railway ticket, user required,
Which
right?
means user interaction, user interaction.
User interference required. I can say
Okay.
like user interference, user involvement required for this kind of online application. Without user involvement, you cannot perform this.
Yes, yes. Okay.
Example of batch application means, anyone? Batch processing or batch application. Example of batch application means, for example, okay, railway ticket booking. Okay, your PNR status. Now
Okay.
currently now it is 150. Okay, after 3
Okay.
hours, it became 100. Tomorrow morning, if you see, it was 30. Tomorrow evening, you got confirmed. Here for this user involvement required.
No, automatically will be
This is what
included.
batch. Example of batch means user involvement not required. User involvement is not required here, but for that online process, user involvement and user interference required there. Okay. Now if you see, which has got more load, online or batch?
Batch.
Mainline.
Which has got more load? Load will be more on which?
Batch.
Yes. Load will be more on batch applications.
Batch.
Batch, the name
Why
itself
big?
saying.
Yes.
Example for this. So if you take most of the financial applications will be like batch applications. And examples of the load, if you talk about load, what are the examples you can say like?
It's a financial application in the sense banking market only.
Yeah. So if you take example of, for example, batch application example. For example, every month you will get bank statement generation.
Yes.
Bank statement or credit card statement generation. Phone bill generation. All these are online or batch?
Batch automatically will be generated.
Means millions and trillions, it is going to generate for millions and trillions of users. So this is user interference required for generating credit card bill?
No, not at
Or
all.
generating bank statement required? Not required, right? Phone bill generation also user
Not.
interference not required. But here I asked like which one has got more load? Means batch, right?
Yes.
Because banks, millions and trillions, here bank statement generation for millions and trillions of customers, credit card bill generation for millions and trillions of customers. So I was just asking which has got more load, batch. And if you take example of online, for example, you made a single transaction, A has transferred the money to B. It's a
B.
single transaction, means
1-to-1.
user involvement required, and here very less load, right? But batch applications require more load. Has got more load. Okay, fine. So here you need to, why I'm saying this, because Hadoop perform batch processing or batch applications, not for OLTP. So, and I got some couple of other queries like for storing the data. Just now someone was asked for processing. Does Hadoop use any languages, existing languages?
Storing purpose, we have to use the Hive, I think, HDFS also.
Hive is not a storage component. Hive is a processing component.
Okay.
Hive is meant, we use HQL language, Hive query language, similar to SQL language. Hive is also meant for processing. And
Okay.
for storing the data, does Hadoop use any database internally for storing its data? No, Hadoop doesn't use any databases for storing its data, because databases has got lot of drawbacks as compared to Hadoop. Once again, I'm saying as compared to Hadoop. So despite of those drawbacks, still Hadoop doesn't go with any databases for storing its data. Instead, it is going with a file system called as Hadoop distributed file system. So for storing the data, what Hadoop uses? Hadoop distributed file system. And for processing, Hadoop uses an execution model called MapReduce execution model. MapReduce. Currently, like Spark is also mostly preferred.
Scala.
Scala is a language.
Okay.
See here, one thing what people generally, once again I say, Spark.
Okay.
Spark and Scala means Scala is not a kind of technology. Spark can be implemented by using Scala language. Spark can be
Java.
implemented by using Python language. Spark can be implemented by using Java language. Spark can be implemented using R language. These two things are not used at all, but today, like in the industry, Scala and Python is mostly used for implementing Spark. Spark is an execution model implemented by using Scala language. Spark is an execution model implemented by using Python language, we say as PySpark.
File Spark.
Okay. Fine. So Spark is an execution model. MapReduce is also execution model. So both are used for processing. Okay. Fine. So Hadoop is meant for storing the data and for processing the data. It can store and can process the data. That is huge data. Okay. Fine. So these are the HDFS. And now have you understood what is big data? How data are getting generated? What are the sources of the data? What are the types of data? And what are the services provided by Hadoop, like storage and processing? For storage, we use this HDFS, and for processing, MapReduce or Spark. Okay, next, observe this. You may ask some couple of queries, right? I'm saying like for storing the data, Hadoop not using any databases. That is one. You may ask why databases can't be used for storing Hadoop's data at the backend.
Why we are not using the database in this Hadoop? Because we need to storage the huge volume of data.
Okay, that is one reason.
Okay,
And
is it not
unstructured
possible
data.
to store the? And one more thing is we have to store the structured at the same time, semi-structured,
Yes, yes.
unstructured also.
Just now I was saying
Okay.
that the main thing is databases can store only structured data. They cannot handle unstructured or semi-structured data, as you said. And one more thing is
Unstructured data.
huge data generation. Huge data if you want to get stored, not possible in databases. Okay, let me
For
just
example,
okay, for examples
In
you want.
addition to this, hello. In addition to this, we can also add the point of relational database subject also, because in generally Hadoop is supporting the large data set of semi-structured and unstructured kind of data. We cannot establish any kind of relation among the one object to another object. That's why we are going for the HDFS probably. This is the reason, I think.
Okay, let me brief you about one by one. See, observe this. Drawbacks of databases. Okay, I'll come back to this drawbacks of databases. So this is what, okay, one second. First you need to know, once again I'm saying drawbacks of databases compared to Hadoop. But
okay.
Compared to Hadoop only I'm saying databases okay, databases are going in the market. Even Hadoop in the market also, still databases will be running in the market. Once again I'm saying, generally people in the demo, students will be asking, if Hadoop in the market, then what is the necessity of databases? When Hadoop can store and Hadoop can process the data, means still if Hadoop also comes in the market, I'm saying that databases are not going. Why? Because databases for online transactional processing, OLTP, Hadoop is for batch processing. And
Okay.
once again you see this storage and processing. Okay, Hadoop is for batch processing. Millions and trillions of records are for single transaction, or those you can go for this Oracle like MySQL for these databases. And once again, for a single record, can you go for a Hadoop? Means yes, I can go for Hadoop also. But Hadoop is bad for small data. Hadoop is bad for small data. Hadoop is good for huge data, bulk data, or batch of records for this. Hadoop is bad for small data. Okay, fine. Drawbacks of databases. First, very less storage. Very less storage. Generally, I'll take demo.
When you are compare.
1 second. Let me complete.
Okay.
I'll be taking demo of 2 days. In a single day, we cannot demonstrate all the things. So let me go in a systematic way. today and tomorrow. Just I will be continuing today's demo. Tomorrow also you can just log in with the same time, same link. So both the days we will be going with the demo session. Very less storage. First one. Second is most of the databases no parallel processing. No parallel processing. Generally, if there is parallel processing, then only you can achieve more speed, right? If you take a labor example,
I understand.
if you take a labor example, a single person constructing a building take huge time, right? In each place, if you keep some 10 labors, so the speed increases. If you just double it to 20, and if you double it to 40, if you double it to 80, then you can achieve more speed, right? Within a short time you can complete the building. In the same way here also, if there is parallel processing, then you can achieve more speed. But most of the databases no parallel processing. And I'm saying like if volume increases, observe this point, volume increases, speed decreases. Volume increase. If you go with a labor example, a boy carrying 5 kg of bag, he can run with that bag. But if I increase the volume of the bag to 10 kgs, the speed decreases, right? If I increase furthermore to 20 kgs, he can walk with that. But if I make it to 50 kgs, he cannot even walk. So if volume increases, the speed here, if I go with the database point of view, observe these queries. See the query. I'll just going to give the proof. Select sum of amount, total amount from sales one. Select sum of amount from sales 2. Select the sum of amount from sales 3. Now observe this. Select total amount from sales 1, sales 2, and sales 3. Sum of amount from sales 1, sales 2, and sales 3. Think that sales 1, you got 1000 records. I think that you got 10 records. Here you think that you got 1 lakh records. Here you think you got 1 crore records. Now, which query is going to execute faster among these 3? Total amount of 10 records or total amount of 1 crore records? Which query is first query, right? The first query is to execute faster as compared to other. As volume increasing, speed decreasing, right?
Performance.
Next, if you take yes, I'm saying like if in databases complexity increases, speed decreases, I'm saying. If complexity increases, speed decreases, I'm saying. We go with a labor example. So for example, try to answer. What is 3 into 5?
50.
7 into 6?
42.
17 into 9? 29 into 32? Try to say.
It will. Here complexity is there.
So here
No complexity.
decreasing, right? Labor X. Now if I come to this, same, I'm just copying the same example. Take a copy. Sum of amount from sales 1. So these 3 queries once again. This time not sum of amount, I'll take like average amount. This time standard deviation of amount. Standard deviation of amount. Sum of amount, standard deviation of amount, and this average amount. Which all sales one, sales one, sales one. Sales one, it's consisting of 1 lakh records. Which now observe this, which query is going to execute faster among these three?
First one.
Which query executes faster? Again, see first query because
Sum.
average. Yeah, I'm getting sounds again. Please mute. Sum of amount from sales one, average amount, average. See, if you are getting any kind of background noise, please you can just give a response to the chart panel. Average amount. See which query executes faster means again this first query, right? Average amount is a two-step process. Sum to be calculated, next average to be calculated. So as compared to the first query, second query takes more time, right? But if you see the standard deviation, lot of internal processing required as compared to the other queries, it's taking more time, right? So query to query, complexity increasing, speed decreasing, I'm saying. And the major drawback of databases, now we see the fifth one. They can handle only structured data, can handle only structured data. They can handle only structured data. Okay, they cannot handle unstructured or simple. For this also, let us see one example. Like observe this. For example, you want to take reviews for a particular movie. Okay, these are users review. User 1, user 2, user 3, 100 users giving the feedback. They are saying giving the feedback in the form of zeros and ones. User 1 saying 1, saying 0. If the movie is good, saying 1. If the movie is bad, saying 0. If movie is good, saying 1. Now, in a structured format, rows are there, columns are there, 2 columns, multiple 100 rows are there. Can I write a SQL query, a database query to count the number of ones, number of goods, number of ones? Yes or no? Try to answer, those from database background. Can I write SQL query or
Yes.
database query to count the number of ones and zeros? Count aggregation. Try to say
Yeah.
me that select
Select.
review wise I want to count. Review wise count I want. From which table? Reviews table. From reviews table. Group by
Review.
review. Singular output. Also this single grouping, single aggregation, we say, those who got knowledge. Single grouping, single aggregation. Output, for example, review 1 is there, review 0 is there. Group all that ones, and I want the count, and zeros also I want the count. You got like count 90 for this, 10 for this. 90 people saying movie good, 10 people saying the movie bad. Okay, this kind of data you can handle, can be handled by the database. But generally, the users giving review, will they give in zeros and ones? All right, they are going to give in their own text format. First person saying movie is good. Second person saying movie is not good. third person saying something like movie story is not good. So now can you write an SQL query to count the number of goods and bads? Can we write an SQL query or not? To count the number
Yes,
of goods.
yes, we can write.
Yeah, yeah. How come?
We can just teach the substring of, we can extract the good and bad separately and count this.
Okay. If, as you said, okay, you can extract only that substring. Okay,
Good
and we
and
can.
bad.
But here not good also has got good, right? It gives wrong computation. Even not good also has got good, right? 100 people
Yes,
saying 100 people saying 50 people saying not good, 50 people saying not good, 50 saying good, 50 saying not good. Means in all the 100 statements good is there. Will it say if you go for the keyword count, you will get the count as 100, right? But it is wrong computation. You should get only 50. So even we cannot go with this. This kind of data can't be handled by the databases. Even if I talk about a semi-structured, unstructured kind of data, can't be handled by these databases. Okay. Once again, I'm saying databases drawbacks as compared to Hadoop. So despite of these drawbacks, very less storage, no parallel processing, volume increasing, speed decreasing, complexity increasing, and you can handle only. So Hadoop is, despite of these many drawbacks, Hadoop still doesn't use this databases for storing its data. It is going with a special kind of file system called Hadoop distributed file system. Instead talking about the Hadoop advantages. Please be in mute.
Some kind of noise.
They have not. Please be in mute. So everyone, please try to be in mute. If you have got some, okay. Next is I was discussing about drawbacks of databases. Hadoop advantages. Hadoop. Let me discuss about Hadoop advantages. Okay. Hadoop advantages. Okay. Before I go with Hadoop advantages, first you need to know the basic architecture of Hadoop, so that you can just come with, from that you can just extract the advantages. So the architectural part I'll be discussing in brief later, but and I'll give you an overview of architecture, Hadoop architecture. Like Hadoop follows master and slave architecture. Hadoop follows master slave architecture. It won't follow client server architecture. Once again, Hadoop follows master and slave, not client server. Single master, multiple slaves. This one S1, this is S2, this is S3. Okay. This master node. These are slave nodes. Slave nodes, another name, slave nodes are data nodes, we say. Data nodes. Why the name data is master node or name node, we say. So what is this? This entire thing we are going to say it as a cluster. This entire thing we are going to say it as a cluster. Cluster. What do you mean by cluster? Group of CPUs. Group of CPUs. CPUs means nodes connected in a network. Connected in a network. Group of CPUs, nodes connected in a network. There are two types of nodes: master node, slave node. Okay, master node and slave nodes. Master node responsible. Okay, so here why the name data nodes? Because in Hadoop, data stored within the slaves and data processed within the slaves. So data stored within the slaves and data processed within the slaves. Okay. For example, in Hadoop, data stored in the form of files. f1.txt, f1.txt, data stored in the form of files. In database, data stored in the form of tables, but in Hadoop, data stored in the form of files. f1.txt. Okay. f1.txt. Okay. If I think how exactly data stored within the slaves, so here why Hadoop only able to store huge data? Narendra Challa, be in mute. Okay, f1.txt is there, right? f1.txt, if you want to store, for example, slave 1 system 1, I got 1 TB storage, 1 TB storage, 1 TB storage. This f1.txt has got a size of 3 TB. Can it fit into S1? Can it fit into S1 or not? No, right? Its capacity only 1 TB. It cannot fit into S2 also. It cannot fit into S3 also. So a bigger data files, bigger data objects cannot fit into the slaves or the systems. But if you want, you need to
Distributing data.
Yeah. So what you can do is in Hadoop, you are going to divide the data into smaller parts, into n number of smaller parts, in multiple parts. Call them as blocks. Each block is stored across one slave. Each block is stored across one slave. Each means data is getting distributed. If data is getting distributed only, then you can see parallel processing, right? If no distribution, then no parallel processing, right? For example, if you brought some 10 labors, but only one work is there, you cannot give that one work to the one person remaining, making all the 9 members to sit ideally. Divide the work into 10 people and just give it to 10 labors. If a single person does in 10 hours, all the 10 people parallelly they are working in a complete in 1 hour itself, right? In the same way, Hadoop data is divided into smaller parts, distributed across multiple slaves and processed parallelly. Think that here 10 lakh records are stored, here 10 lakh records are stored, here 10 lakh records are stored. So here data getting distributed across the slaves and data getting processed within the slaves. Two things, two advantages you can achieve: huge storage and high speed processing. If you think that there are some 50 slaves, 50 systems, data stored across the 50 systems and data processed by 50 systems parallelly, that's why huge data storage and huge data processing available in the case of Hadoop. So I'm saying like data, where data getting stored in the data nodes, slave nodes, where data is getting processed in the slave nodes, in the data nodes only. If everything data storage done by the slaves and data processing done by the slaves, then what master node will do? Okay,
I have a question, Vijay.
Yes.
So, how this will break a text file into 3 systems.
Say number of sizes by default size.
So one second. So there is okay, a 3 db file is there, right? 3 TB file is there. By default, the data, whatever data is there, fixed size chunks, we say them as blocks. There is a concept blocks. Each block will be of fixed size of 64 MB or 128 MB. We say it's going to be divided. Means some records it will be splitted. The data is going to be splitted in the form of blocks, and the blocks are going to get distributed across the steps. This is done automatically. The file gets splitted and into fixed size. We need to specify the file need to be divided into what size blocks. Means by default, if you're not specifying, like 128 MB blocks you will be getting, but I can also specify, I can configure the block size. What should be the block size? Each chunk, the volume is what I can specify. So it gets divided internally and distributed across the space and process the content.
So Hadoop do it automatically. We just need to specify, maybe give some configuration.
Yes.
Okay.
Yes. Yeah.
Vijay,
What is Devnath? Okay, not a problem. You are in mute.
Vijay,
Yes. Go ahead. Any query?
Hadoop doesn't have any default size. Default.
Default is 128 MB, 64 MB and 128 MB.
Okay,
Default.
it's like is a calculating like file size divided by 64. Like, is it possible to do like that?
Yes. So here, file size is, for example, whatever is the file size, 64 MB is the default block size. 64 MB is the default size of each block. If it is divided into 10 blocks or 20 blocks, each block size of 64 MB, equal size chunks, we say blocks. Later I'll brief you about all this, or how exactly it is stored, how exactly it is processed. But now, how Hadoop is able to accommodate huge data and process huge data means, if data is increasing, you are going to increase the slaves. Means data are getting distributed across the slaves and processed parallelly by multiple slaves. That's why you are able to achieve high speed. Okay. Now based on this, so data getting stored in the slaves, data getting processed by the slaves. That's why we call them as data nodes. Everything that master node has got many other responsibilities. I'll be briefing you those things. But now, based on the discussions we had, now just let us discuss the advantages of Hadoop. First one, unlimited data storage. Unlimited data storage. Second is huge data processing. Very high speed data processing. Unlimited data storage because there is a feature in Hadoop, horizontally unlimited scalability. What is that? Horizontally unlimited scalability. Horizontally unlimited scalability. What do you mean this? Horizontally unlimited number of slaves can be added. For example, these are your slaves. So horizontally keep on adding the slaves like this. Horizontally unlimited number of slaves can be added. Today,
Vijay, sorry to interrupt you. In real time, basically, what is the cluster size of this Hadoop?
So it is going to depend upon project. So it is going to company to company. So how much? What is the cluster size? 40 node cluster or 16 node cluster, 80 node cluster. So it depends. It is going to differ. It's going to change, right? Company to company.
Okay, for mid size, company like for the mid-size project, like what will be the cluster size?
Generally, like we'll be maintaining like 60 node cluster, 80 node cluster.
Okay, okay. Thank you.
So here horizontal. So here observe this. Horizontally unlimited scalability, horizontally unlimited number of slaves can be added, horizontally unlimited number of slaves can be added. Okay, for example, if you are running with a 3 or 10 slaves, your business has increased, your branches has increased, your customers have increased, means your data also increased, right? Means if data increased by 100 times, customer increased by 1000 times, you cannot go with the same number of slaves, right? You'll increase the number of slaves horizontally. And second feature, very high speed processing. Very high speed
Vijay,
processing. Yes, yes. Yeah, go
based
ahead.
upon cluster size also, performance will be increased.
Yes, yes. For example, based on the labor size, for example, for constructional work, based on the labor size, the speed of your construction work increases or not?
Yes, it
For
can.
example, labor example. If less slaves, less. Yes. Yeah, understood. The same manner here also the same thing. Otherwise, what happens if less number of systems, less number of slaves, means if more data, some of the tasks will be in the waiting state. I got 40 tasks, but a job is divided into 40 tasks, but they have got only 20 systems with me, 20 slaves. Means first 20 tasks assigned to 20 slaves, remaining 20 will be in the waiting state, right?
Here, cluster size based upon the company products. How can you decide cluster size
Depending upon the projects, whenever
products only? Mhm.
requirement specifications, everything based on that, we are going to configure that. Commissioning and decommissioning, we say adding and removing.
Okay. For example, is like e-commerce, e-commerce project. Example, I'm telling. Say maybe which cluster they are using. Example,
Which cluster
which
means number
size?
of slaves you are asking?
Number of slaves and at the same time cluster size also.
Okay, okay. I'll give some examples. E-commerce, they are using large number of slaves. So here, unlimited data storage. Okay. For example, one second. Yahoo when first time implemented Hadoop, it went with 4,000 slaves for storing its data. But Yahoo currently going with 12,000 slaves for storing its data. Facebook, if you take the example of Facebook when first time implemented Hadoop, it went with 8,000 slaves or CPUs. Currently, Facebook going with 42,000 slaves for storing its data. So this is what any number of slaves, unlimited data storage can be accessed. Data can be stored and data can be processed. And in the tomorrow session, just why cannot the databases like Oracle or MySQL or specialized databases like Teradata, Netezza, Vertica, why cannot they go for this many slaves? Only why Hadoop can go? What is the limitations there? I'm going to discuss and just compare those things between the databases. Okay, generally for this online transactional processing today, I said like Hadoop performs only batch processing, right? For
Yes.
online transactional processing, but Hadoop to
It's very
perform
bad.
OLTP also we go for okay. Hadoop performs batch, it's perform online processing, both combined together they can perform both online and batch. So today NoSQL databases has got a great demand in the market. Okay,
It's a
NoSQL,
MongoDB. Mongo.
like not only MongoDB, there are many NoSQL databases. MongoDB,
Example. Example.
like MongoDB is there, Cassandra, HBase,
It's
CouchDB, Riak, Peanut. This way, many NoSQL databases are there in the market. The famous are Cassandra, MongoDB, HBase. So NoSQL, not only SQL. Okay. So I was just discussing this advantage of Hadoop, unlimited data storage because of huge horizontally unlimited scalability, very high speed processing because of parallel processing. Because of what? Parallel processing. Okay, and mainly can handle all varieties of data. Can handle all varieties of data. No licensing required. It's an open source. What is it? Hadoop is an open source, no licensing required. Most of the products of Hadoop are from Apache family, Apache product. Apart from this, many other advantages like volume increasing, speed won't decrease, complexity increase, speed won't decrease in this Hadoop. But one major example I give for very high speed processing, storage point of view, Hadoop is proven in the market, but processing point of view, Hadoop has proven in the market. Okay.
Vijay, I think we are over time. So can we connect tomorrow again?
Yeah, just 5 more minutes I take before I wind up. Just I'll give one example. Processing point of view. Yeah, already we are going out of time. Yahoo has conducted a test to check the speed of various databases in the market. Yahoo has taken a table of size 100 TB consisting of 1024 columns, and the task is to sorting the data based on 16 columns. Okay, so what is the time taken by the various databases for this? Oracle has taken 3.5 days to process it. MySQL, it has taken nearly 6 days to process it. But Teradata, a specialized database used for data warehouse purpose, it has just taken 4.5 hours to handle it. But Netezza, one more NoSQL, that is one more specialized database, it has just taken 3 hours. Finally, Hadoop, it has just taken 3.2 minutes for processing it. 3.2 minutes. Where are the 3.5 days, 6 days or hours? But Hadoop has taken just 3.2 minutes. Latest version of Hadoop taken just 1.2 minutes. There is Hadoop proven in the market, storage point of view, even processing point of view. That's why we have got a great demand for Hadoop, especially for data warehouse kinds of projects, wherever we see that huge data is involved. So there is a requirement of Hadoop. And if you see, Spark is very much high speed processing. Later I'll demonstrate about that. We are running out of, it's very much high speed processing technology we say. Okay, so job opportunities in Hadoop, if you see, lot of jobs. And if you see that even if you see there is a great demand for Hadoop developers in the market. So any prerequisite for learning Hadoop means, so everything I'll be covering as part of the course, whatever the things required, not a problem. I'll be just briefing you about all the things, what all the prerequisites.
By the way, are you going to cover the installation part as well, right?
Yeah, everything I'm going to brief.
Step-by-step installation.
Yes, I'm going to show you those things.
Which version?
Everything is practical oriented. There is no theoretical in this. Everything is practical oriented, right?
So are we doing this maybe on cloud or on premises? How?
Yeah, I'm going to show you on this Cloudera and Cloudera distributions, and also in our how to just someone was asking, right, how to install these components, how to components, other things. I'm going to show you that how to create those cluster and how to just install the components on it. Everything I'm going to show you, and how to run on the local system and also on the Cloudera distributions also.
Vijay,
So just want to know this Cloudera and this Amazon Cloud, and these are one and the same thing or a different thing? You just want to know.
No. Cloudera is different. Cloudera distributions, we have got some distributions where we see all the Hadoop components inbuilt. We call it as Cloudera distribution, where inbuilt, it's inbuilt, no need of any separate installation like that, using which you can directly work with those things, right?
Of this Hadoop, sorry, Vijay. On top of this Hadoop, we will go for the AWS. Then what is the importance of this particular technology on top of this one?
One thing, once again, I'm saying Hadoop is meant for what? Huge data store, very high speed processing, huge data storage, and especially today, like I'm saying, HDFS for storing the data, for data storage and for data processing, we go for these things. So in tomorrow session, as you're saying, like you're running out of time, right? In tomorrow session, you can also log in with the same time. I'm going to brief you what I'm going to discuss as part of the course. What are the things? What are the components? Yes, Narendra Reddy. Yes, I'm going to discuss the flow of that, how the flow goes, everything.
Vijay, I'm belongs to Java.
Yes.
Okay. So, what is the job market and Spark with Java?
Spark with Java means only like few companies as of now they are going with Spark with Java. Mostly like Spark with Scala and Spark. Scala is almost like it's a simpler form of Java, I can say. It's very simple and easy, like but not even Java, I can say. Very simple. It looks like taken some features of Python and Java. And only some companies are preferring a Spark with Java, like Value Labs, and there are some other companies, very few companies, but remaining all, you need to go with Spark with Scala, Spark with Python. But I'm going to discuss, as part of the course, I'm going to discuss Spark with Scala language.
Okay. Thank you.
Okay.
So why not just one more question, like add on this? Why not companies are preferring to go with Java? Because I also belongs to the same. I'm shipping on the same boat, yeah.
Okay. If you see that Scala is much, if you see the Scala language, Scala has got both object oriented and also like procedural oriented. Both you can see, it's both, you can go with both the forms. So Scala will be much more flexible, especially Scala is a native language of Spark. See what is this? Scala is only for big data side. Scala is language is only used within the Spark environment. Means it is much more flexible than Java, it is saying. It's a like kind of hybrid language, I can say. Scala, as compared to as compared to Java, Scala is a hybrid features you got. Okay, some flexible features you see, and some easy coding, very less coding you can see. Less coding you can see, and simple syntaxes you can see as compared to that. You'll observe. Okay, but features will be like the same like Java, but it's not Java.
Okay. Yeah, maybe there will be some syntactical things.
But Java, if you go like mainly like huge coding required, lot of programming knowledge, huge coding is required mainly. That's why to reduce it, yeah, to go with that. So even not a problem. This knowledge is going to help you out.
Okay, okay.
One thing, Vijay, okay, because of this training, okay, what we learned, okay, I need to show like a real-time example. I have a real-time example in Spark with the Scala. I need to put in resume itself is very advantage or based upon this training session.
Yes, yes. Just now I was saying like I'm going to take near. Yeah, if you can see that course structure, you can see everyone. How much brief, how much in depth we are going into that Spark and Scala topics, and also in the Hadoop topics. You can just, and tomorrow I'm going to brief you about what I'm going to cover, and also once you can check the course content, how brief and how what will be the depth of it. Like a 3 years, 4 years guy, how much experience he is going to achieve, you will be achieving the same thing.
Okay, okay.
Fine.
Actually, I have
Just
four
one
years of
question.
experience only. That's why I'm asking.
Yes, yes. Means those people who are new to this
So,
Hadoop,
Vijay,
generally,
we will be covering the project also. Any project?
yeah. At the last, I'm going to show you the flow execution of this entire thing application. Okay, fine. It's already 7:25. Okay.
Okay, okay.
So still,
Thank you, Vijay.
what
I think is pretty new. So I just wanted to know if we will be covering any hands-on things. So that will be really helpful.
so
Yes.
only for the first 4 5 days you see some kind of later everything will be practical. First of 3 4 days, why? Because you know to know about that Hadoop architecture and Hadoop what all those things. But later everything practical oriented only. There won't be any theoretical. Even I want the sessions to be interactive. For every statement I type, every practical statements I type, I want response from you. I want the sessions to be interactive. Nothing theoretical. Only theory is to just what is Hadoop, what are the advantages, comparisons. Okay, but later once you enter into the technical part, everything practical only. There won't be any theoretical. Okay, fine.
Mhm.
And one thing, what I suggest to people is if you do that practicals that day itself, and you can experiment those things, you will feel very easy and very simple. But once in a week or every 10 days, if you sit for the practicals, you cannot. Daily you can experiment, you can do the practicals, and you can communicate with me. You can ask queries, interact with the class, response with the answers. And I'm going to give some tasks and assignments working on those. Right? Okay. So clear notes will be provided for the practicals, each and everything. Clear notes for each and every practical sessions. Okay, fine. Okay. So I'll just stop here for today. Meet you tomorrow at 6. Fine.
Thank you, Vijay.
Thank you,
Thank you very
Vijay.
much.